Annotating the data in a correct way will be one of the enablers of autonomous vehicle.
A lot of researchers, they were used to having fixed data sets.
How about data security? Because you mentioned that you host the data at your premise.
And this is why we developed a module there called the UII anonymizer, which basically automatically, also with deep learning technology, blurs and anonymizes faces and license plates.
And you're talking about billions of annotated objects in an automated way. Well, that's a big statement. I'm really excited about it. Hello and welcome back to another episode of Matrix Tech Talk. Today, we have a super exciting topic and someone very exciting in the autonomous vehicle industry. We have today Philip Kessler from Understand.ai, the CDO of Understand.ai. Philip, welcome to Matrix Tech Talk.
Nice to meet you. Nice to be here. Thanks for the invitation.
So a little bit of an intro about Philip. Philip is the CDO and the founder and one of the co-founders of Understand.ai. He is a computer scientist. He studied at Karlsruhe Institute of Technology. He was involved in automotive research for a long time. One of his assignments was with North America with Mercedes-Benz Research and Development. So Philip, why don't you tell our audience a little bit about yourself, your passion and your background? And yeah, off you go.
So a little bit of background to myself. So autonomous driving, I think, is something where we all passionate about, especially I think in the recent years where we saw more developments in this area. I think there's research since the 70s in that area, and actually my grandfather was involved in that as well in the early research. So he worked at Daimler at Mercedes trucks before and did a lot of testing on these autonomous trucks and so on. And I remember when I was a small child, he took me on one of these large trucks with some sort of advanced driver assistance capabilities, and I was just amazed as a small boy, basically sitting there in this large truck and seeing what is potentially possible in the future. And I think now we advance quite a lot into the future. And basically, I studied computer science, as you mentioned as well, at the KIT. I worked there in a small student group where we developed a small autonomous car and tried to compete in a let's say virtual racetrack on that. And then I went to Mercedes Research in the Silicon Valley. And worked there in the data collection, data analysis field. But lots of my colleagues were also involved in the autonomous driving area. And I was really passionate about that topic. And always when we worked on these topics and when we worked with machine learning and AI, we always struggled with having the right data and getting the right data. And so it was mainly about getting the diverse enough data, so diverse data sets, the right quantity of data and the right quality of data. And this is kind of why we founded Understand.ai then. So Mark Mengler, my co-founder, and I, together with the founding team, to try to tackle this problem and try to solve that problem of the rider and getting the right data in the right quality and quantity.
Fascinating, Philip. So you mentioned that you have been passionate with automotive from your childhood. Now, what made you an entrepreneur? What drove you to become a founder, a co-founder? Why did you found Understand.ai?
I think it was mainly passionate about the problem first. So it was not so that we said, okay, we want to be an entrepreneur and whatever, ride with our bike to the co-working space and have a happy hour at 5 or something like you see it sometimes with the stereotypical founders, basically. So we really wanted to solve a problem, and we were doing the machine learning research in the beginning ourselves, and we struggled, like I mentioned, with this problem of not having enough data or having enough high quality data. So initially, we just wanted to solve a problem for ourselves and for our colleagues. We started to talking to other people about this problem, and more people became interested in that. And this is actually how we, let's say, went into that area. So it was not so much that we said, okay, we want to start a company and make a lot of money in that space. It was more, okay, we have a specific problem which we want to solve for ourselves. And there are a lot of other people having the same problem and who are willing to, let's say, invest money and time in that problem. And that's kind of how the company grew.
I understand that. However, what I want to ask a little bit also personally, I mean, you could solve the problem also in a 9-to-5 environment. You didn't really need to take the risk and take a crazy lifestyle of an entrepreneur. Like what you mentioned, the stereotypical life of entrepreneur Actually, in practice, it's much different. It's like, you hardly have any holidays. You are always in meetings. You're working whenever you just are able to work. And the reason is you like doing it. It's not that you're suffering. You enjoy doing it. So you're responsible for yourself. There is nobody to take care of you. There is no boss. You were kind of like the CTO, the top position of the company. Yeah. So what made you, take such audacious move that, yes, I'm going to go and found a company? And when you did that, was it like a venture capital funded, or did you guys do it yourself? How was it?
From my personal motivation, I always driven by where can I learn the most. And during that time, actually, when we started Understand.ai, I was still studying, and I learned during my studies, and I'm also doing my internships and so on. But when I started the company, the learning pace accelerated so much. And this was really motivated me to double down on Understand.ai and to focus 100% on Understand.ai. It's really the learning curve, because as a founder, and you know that as well, and some of your listeners know that as well, that you're responsible in the end, and you have to learn things very fast. You cannot take years for certain things. You cannot wait until the next course on Udacity is out or in your university is out on a certain topic. You need to learn it today, basically, because you need to apply it tomorrow. And that's, from a personal standpoint, the pace and the amount of things you learn when you're being an entrepreneur, because you're facing so many challenges, and also it's in so many different areas, on technical areas as a CTO, but also in business areas and people management areas and so on. And this is what motivates me personally, this learning pace. And to your follow-up question, basically, how did we start it? So initially, we started obviously on our own with, let's say, our own capital. In the beginning, we did not pay any salary to the early employees, to the founding team. We just gave out shares of the company. And then at some point, we invested money from the classical 3Fs, so friends, family, and fools. So we raised some money from just our family and raised some debt as well. And then we got in some investors who believed in us early on from our headquarters in Kessler. We had 2 investors from Silicon Valley. We had an investor, and also from London, we had a VC. And they helped us to scale the company further.
And at what point, when you were actually raising friends and family rounds and the early venture capital round, was it that you were making some revenue, or did you invest a lot on the development?
So when we raised from the friends and family, we did not make any revenue at that point in time. When we raised from VCs, we had some early proof of concepts, which were paid at that point, but it was still early on from a revenue standpoint. And we invested mainly in the tech. And I would do it a bit differently when we started the company and we were first-time founders, and especially if you are technical founders. And both my co-founder and I were technical founders. We invested a lot on the technical side because we believed everything can be solved from a technical standpoint. And as you know as well, it's often a combination of, let's say, business solutions, go-to-market, and the technical part. You need to have, let's say, best-in-class people on both sides, both on the technical side as well as on the go-to-market side. And this is, I think, what we underestimated in the beginning, what we changed now, but we invested mainly on the technical side.
Thank you so much for mentioning that. And you're not the only one. I've seen so many people, so many tech entrepreneurs, my friends from study time, they love the technology so much, they forget the feel of business is not technology. It is, by the way, Prost. Just to Kessler. So they forget that what propels a business is sales, right? So there is an interesting fact that most successful SaaS companies have more salespeople than engineers. Now I'm getting back to what you started with. You mentioned that you had a problem to deal with, right? And that problem motivated you. You wanted to come up with a solution. What is that problem, and what does Understand AI offer today?
So very broadly speaking, the problem is data. And as I described early on, we can classify it into 3, let's say, subcategories. It's the quantity of data. So how much data do I have available? The second thing is the quality of the data. And the third thing is the diversity of the data. So do I have, if we talk specifically about autonomous driving, do I only have recordings of sunny highway scenes from Munich to Ingolstadt? Or do I have a lot of diverse scenes with people running in front of the car, and deers and night scenes and rainy scenes and snow scenes and so on? So these are the 3, let's say, subcategories of the data problem. And how we solve it at Understand.ai, or how we try to deliver value to the customer, is the data annotation problem is mainly solved manually today. So there's Tesla, which has around 1,000 people sitting in Lagos, Nigeria, From a Waymo side, we heard at some point that they have around 3,000 to 4,000 people sitting in India annotating data more or less in a manual way. And from Baidu, we heard at some point that they have around 20,000 people sitting in China doing nothing else than annotating the data. And annotating means they get images, for example, from the Tesla drivers, and they look at each image and say, okay, here, this is a pedestrian, and here's another pedestrian, and there's a sign in the background, and there's a traffic light, and so on. So this is called data annotation. And this is mainly done manually. And Understand.ai basically provides value in automating that part as much as possible. So we have an AI engine and a tooling around it, which is used by one of the largest companies, not one of the largest OEMs and tier ones, to solve that and to automate the annotation part.
Now that you've mentioned this problem, autonomous vehicle industry is estimated to be an $8 trillion industry. So it's a huge industry that we're talking about. I mean, Tesla stock going high is based on the value of such estimation, right? Now, annotating the data in a correct way will be one of the enablers of autonomous vehicle. Now, how big is the annotation industry today?
That's a tough question because it's also quite a, let's say, changing market and so on, and quite a different market. Honestly speaking, I would have to look up the number. I have to cross-check the number. But in general, there are two things where I can talk about a little bit to give you a bit of a market perspective and a market size perspective, how we divide the market. So we call one segment is the training data market. The other segment is the validation data market. So the training data market is where I want to train my algorithm to recognize pedestrians, recognize signs, recognize cars, for example. So the use case is I'm a perception engineer at Waymo, I'm a perception engineer at BMW or Magna, and I want to train my perception algorithm, and I need data for that. So that's the training data market. And you need normally thousands and millions of samples of certain situations to train your algorithm properly. And we also have a long tail problem here that it's not enough to have, like I mentioned before, just the sunny images from the highway from Munich to Ingolstadt. You need really to have a diverse set of data. And it's often a quite iterative approach. So normally you train your algorithm, your perception algorithm on a certain set of data. Mm-hmm. Then you benchmark this algorithm on a validation set. And you check basically where you have errors. So where's your algorithm making errors? And based on these errors, instead of manually basically programming, okay, I need to recognize this now, I need to recognize that now, you basically add more data to your training data set to fix these errors. So for example, let's say your algorithm performs very poorly on people and pedestrians with sunglasses. You need to check your training set if it includes people with sunglasses or people with masks. Now with COVID, basically pedestrians look quite different today than they were looking for 3 years ago. And this is a challenge. So your training set needs to be quite balanced. And this is basically the training data market. And the validation data market is where before you bring a car into production, before you can put it on the road, you need to prove to the authorities and to the OEM if you're a tier one, that your algorithm is safe enough, and that in only one of a million or something cases, I think you're a bit more an expert, I think, on ASIL-D and so on, and these kind of certifications. But you need to prove that your algorithm only makes certain number of errors in a certain time frame. And this is where companies today drive around the globe, collect data from 16 countries and collect thousands of hours, basically, and they need to annotate these data sets manually, or need to annotate them, and then basically cross-check that with their perception algorithm, which they want to bring onto the road, and basically calculate the KPI. How good is the algorithm today? And is the algorithm ready to be put on the road or not? So this is the validation market.
Very interesting. So you mentioned so many stimulating points, and I'm going to touch one of those one by one. Let's stick with the validation. Are you talking about validating testing in simulated environment?
This is one part as well, but I was mainly referring to the real life data. So there's a certain amount of testing you have to do, and some you can do in the virtual world with scenario-based testing and so on, which we, together with our mother company, DSpace, are also doing. But I'm mainly referring as well to the testing in the real world, where you really have to have a real car on the real road, equipped with sensors, and they're collecting data basically on the street, and this data set needs to be annotated.
Okay, and then you validate it with the decision that they already made in the street. whether their decision is correct or not.
Exactly. So you record the decision basically of what the car would do basically. You compare that what your annotators would say. So basically a semi-automated annotation, you compare the output of this stream, of the data annotation stream, with the output of your algorithm, of your perception system, and then compare it side by side, how often they agree versus how often they disagree.
I love that because actually this is where Understand AI and Matrix kind of like come together, because as you mentioned, when it's ASIL-D, the requirement is you not only have to do the testing, you have to also do the test validation. So there was this use case that I often talk about, that you have those Euro NCAP scenarios. We're not even talking about autonomous vehicle. We're talking about, regular ADAS, automated emergency brake. And there is a dummy walking in front of you, and you see if your brake is activated or not, triggered or not. Now, although the cases are run in the test environment and they pass, also because it was ASIL-D, we're required to go through the protocol and look at the video and see what the CAN protocol did, the CAN trace, from the CAN trace, what the software actually did and what it's supposed to do. Is it matching or not? So are you doing some kind of automation to do this kind of scenario?
Where we apply the automation is basically mainly in the labeling process. So where basically normally you would have to spend a lot of effort, which normally does not fit into your timeline and in your budget of the validation effort to annotate the data, to create this ground truth, how people call it, that you can compare something. So the ground truth, you can compare it with the output of your algorithm. And this is where we automate, or where we use automation in the ground truth creation. So not so much in, let's say, the deep analysis, okay, where's the error, more in terms of spotting the error and where are false negatives and false positives of your algorithm.
That makes sense, because once you have spotted the error, then you need a human expert to dig in.
Exactly. Why is the error there? And do I need whatever, do I have an error in my algorithm or in the reasoning behind it and so on? We are more in the area of spotting the error and helping to raise the flag and say, hey, there's something wrong.
Again, coming back to the points that you mentioned one point is, data is the name of the game. In machine learning, there is this saying that if your algorithm doesn't work, blame the data.
And that's quite different, I think, than we had it in the research. If we come back to the beginning, I mean, a lot of researchers, they were used to having fixed data sets, like Cityscape data sets, or there's the New Scenes data sets from Aptiv and so on. So there are lots of data sets out there. And normally in research, you have a fixed data set and you try to optimize your model performance towards this data set. But actually in the industry, in the real world, so to say, a complete other way around. Your data set is not fixed, your data set is variable, but kind of your model performance is fixed or has a certain threshold you need to go over this threshold. Otherwise, you cannot put it in a road. And that's kind of, I think, an interesting change as well for a lot of people when they're going out of research into the industry to have this different mindset that, like you just said, the data is actually more important than the algorithm.
As you have mentioned, data is going to change. I mean, you gave some fascinating example. Even a year ago or 1.5 years ago, we didn't have this COVID problem. We didn't have masks. Yeah. And this is where, from a safety perspective, we have amended the standard ISO 26262 standard and created SOTIF, safety of intended functionalities. The problem in SOTIF is, which we don't yet know how to solve, is the unknown. If you know something, you can take safety measure. But if you don't know what you're going to see, and the environment is there will always be unknown. There is no way you can come up with data set that covers everything. So how? No way. Yeah. You're saying that the model is fixed and you'll retrain the algorithm and push a patch. Now, I'm making an assumption that, the data will change in a way that your algorithm adoption is not needed. So how will Understand AI technology will make this process easier to ship a patch whenever there is a change or new data? How often do we have to do this kind of data annotation, new data, new patching? Is it a constant process, or is it like you do one time a huge annotation thing and you ship it and you're done?
Well, that's a very great question. I would divide it again into these two kind of categories. If we look at training data, it's a highly iterative process, and there you really need to do it on a constant basis to update your model and to change your model. And how Understand.ai is helping there. So we, as a company, we focus on the tooling side and on the product side of the data annotation process. As I mentioned, the core USP of Understand.ai and how we help customers is the automation part. And basically, we provide a very flexible tooling with also workflow management and so on, where you can really easily say, okay, today I have this need of the data with the following specifications. Tomorrow I have a different need with a certain change of specifications because I learned from my model that I need to annotate. Now the mirrors of the car need to be included in the box or outside of the box, or now people have masks, so I need to have this as an attribute as well. As I mentioned, the attributes and the annotation is quite an iterative process, and we support the customers with a very flexible tooling as a service where they can just configure the tooling, configure workflows, and change them as they have to adapt their algorithm and their data. That's the highly iterative process for the training data part. For the validation data, it's rather, let's say, a fixed process in terms of that you have a certain start of production which you want to hit, because SOP date, and then you can calculate backwards by when. If I need to have a SOP date in whatever 23, I need to have at a certain point, I need to have my validation run completed and a certain KPI reached so that my ground truth and the output of my algorithm is in 99.999% correct. So this is more aesthetic thing where at some point I need to collect a lot of data across the globe after my algorithm is more or less freeze so that I can then prove to the authorities and to the OEM that the algorithm is good enough. So this is more aesthetic thing in the validation part, and the training data is more iterative part.
There's one point you mentioned that data globally. So why is it required to train the algorithm with global data when you can kind of know that this vehicle will run within Europe? Yeah, I mean, if you're selling. So, I mean, in automotive, when we ship a vehicle to the United States, we have certain configuration. And, the other day, my car dealer was telling me, if you want to buy the car for United States, you can't drive it in Germany. You have a different configuration for that. So we are actually building car for a specific region. And when it comes to AI, why do we need global data?
Yeah, I think also a very interesting question. I think from my perspective, why we need global data is that the algorithm is able to abstract properly. The challenge is if the data or if the algorithm is only seeing a very narrow data set with a very, let's say, narrow use case in a certain geography, it's very difficult for the algorithm to abstract to unseen cases. What you mentioned before as well with the unknown unknowns, so the things we don't know yet. Maybe with the next pandemic, we have to wear whatever crazy hat or we have to do something different. Basically, we don't know it yet. And let's say the more diverse the data set is, the more, let's say, global data coverage we have, the more variance we have in our data set. And with this variance comes a higher abstraction level of the algorithm. And this means in the end that the algorithm is able to react faster and easier to these unknown unknowns. If we only have a very narrow use case and only trained it in whatever, let's say, Germany, it will be very difficult for the algorithm to abstract from this narrow data set for more use cases, more examples which he has not seen yet.
Well, and that reminds me, there's this concept in machine learning, as you know, called overfit and underfit. Your algorithm may overfit, and what you're essentially saying is if I just train my algorithm with the data from Germany, it's going to overfit the system. It's going to be probably working very good in a known scenario, but the moment there will be some unseens, it's going to struggle.
Exactly. And the world is changing and the world is global today. I mean, as we all know, and as we I think all see with the pandemic, how global we are. Like there will be always, let's say, cars from the US imported to Germany, and all of a sudden you have a big pickup truck in front of your autonomous vehicle, which you've never seen if you only have data from Germany. But now all of a sudden you have this car and you have to recognize it as well. So that's why I think it's important to have a global data set as well, or global data.
Got it. Now, what are the use cases that you're actually handling right now in terms of perception data for autonomous vehicle?
Use cases, you mean in terms of use cases for the customers, or what kind of customer use case he has, or what do you mean specifically by use case?
Exactly, yeah.
So the use cases, I think, are a little bit similar to what I mentioned before. So one use case is obviously training my algorithm, so which is about the training data, which is mainly about this iterative process. For the validation use case is really to calculate the KPIs, to report the KPIs. And there it's really about the volume, basically, and covering a large volume with the global data set and so on. And in addition, maybe, or to take it one level deeper, different use cases are also the different annotation types. So one use case is, for example, 2D bounding boxes, which is a very simple use case where you just draw a bounding box around a car, a pedestrian, or a traffic light, and you say, okay, this is a traffic light. Another use case is semantic segmentation, which is where I mark every pixel in the image and say, okay, this pixel belongs to pedestrian. This pixel belongs to a car. This pixel belongs to something else. So this is another use case, just what we call semantic segmentation, which is one level more fine granular. Unfortunately, we cannot show pictures here. It's more a visual thing, but you can check it out on our website. We have a few examples there. And then a third use case, which is quite growing, is the 3D or the sensor fusion use case. So a few years back, a lot of the companies were using only camera data for perception, but in the recent years, LiDAR and radar, and I think you recently had a talk with a radar company as well here in your podcast. And I think the battle is not won yet between the LiDAR guys and the radar only guys. But this is a use case where we've seen a lot of rise in the recent 2 years, 3 years. And this is where Understand.ai, I think, can provide a lot of value to customers, because we focus on that is the sensor fusion use case, so that you not only annotate camera data, but you have LiDAR data, you have radar data and camera data, and you need to annotate that all in a proper way and in a sensor fused way. And this is a very challenging part, because it's very easy to build a 2D tooling. There are lots of open source tooling as well. But once you have to, let's say, put a LiDAR point cloud, which is super dense, into a web browser and annotate it in an area where the internet connection might not be super stable and the hardware using is not a MacBook or let's say a big laptop with a GPU from NVIDIA, but is rather maybe a Chromebook, then it becomes challenging. And this is, I think, one of the most, let's say, promising use cases, or one of the growing use cases where we see further demand, I think, in the future as well.
That's fascinating. So you also annotate such images like point clouds from LiDAR and data that has been fused by the sensor fusion unit.
Exactly. And I think we're one of the few companies which are, I think, specifically focusing on that, because it's rather a complex task. So a lot of the companies focus on the 2D part, like 2D boxes, 2D segmentation, and so on. And at least to my understanding, there are very few companies who also are able to, let's say, solve these more complex tasks, like 3D segmentation, so a segmentation on the point cloud, which is very challenging, or 3D bounding boxes, and so on.
Got it. So we're not only talking about video data, we're also talking about more complex 4-dimensional LiDAR, radar data. So after fusion, it's again another complex type of data set. It's not the camera data anymore, it's not the LiDAR data anymore, it's not the radar data anymore. It is even more complex. So how does that data look, and how do you annotate that?
Yeah, I'm not sure if I understand correctly, but so what we're doing basically when we're talking about the sensor fusion annotation is that the first challenge is to fuse all the data points together and to make sure that you have, to a certain timestamp, that you have the right radar point cloud and the right, let's say, camera image, which is calibrated accordingly, and that you then in this fused world, which we then visualize in our tooling, that in this fused world, you annotate basically, and you do the bounding boxes, or you do the 3D segmentation. And then that you output at a certain timestamp, that you output the correct position of the car or of the pedestrian or of whatever else. And this is normally the complex challenge to fuse all these sensors together and to make sure that they're at the right timestamp and images are rectified and so on. And you have normally multiple LiDARs and different radars and so on. And to fuse it all together, that's normally certainly a challenge.
Do you take care of the fusion part, or is it like when the fusion is done, you just annotate? What's your territory? What's Understand.ai territory?
We are motivated, I think, by problems and by solving problems. And this is a big problem for customers. And obviously we could say, okay, this is your problem. You have to calibrate it and you have to fuse it together. But it's a big challenge for our customers as well. And we obviously try to support them along the way. It's not that we say, okay, you have to deliver everything to us in a perfect way. This is, I think, not how it would work. We also support them. We have a dedicated customer success engineering team who sits together with the customer and tries even to fix calibration issues afterwards and so on. So we're really trying to support the customer end to end, not only with the data annotation, but also with this import and calibration part and so on.
Got it.
The big challenge is if you don't calibrate it right, and if the import things are not done properly, you can annotate it as precisely as you want. It will all be screwed up in the export or in the output, because if you did not calibrate it properly, then there's an offset in your boxes, and therefore you will train your algorithms on screwed data. And this is very dangerous. As we all know, I think if we have errors in the data, this will proliferate to the algorithm as well. And that's why I think it's important as well to have the import right. And it also influences the automation. As we're using a lot of automation, it's key as well that the data is as accurate as possible. And let's say the better a job we or the customer or together we do in the collaboration, the easier it will be for our system to automate it and therefore save a lot of time in the manual annotation.
Got it. I mean, it totally makes sense that if you don't do the fusion right, if your frames are not synchronized in terms of different sensors like LiDAR, camera, and radar, if there is a delta, it's just not going to work because the frames they have to correspond to the same frame, and it is not a trivial task. You mentioned different types of annotation, namely actually 2 or 3. You mentioned 2 for sure. Maybe there's a third one. So boxes, then semantic. So what are they good for, and what are they needed for? Those types, and if there's any third type that I forgot.
What are they good for? So the 2D bounding boxes are mainly used, I would say, in the validation part. So on the validate system, it's mainly important to identify where you have false negatives. So where do you miss certain objects? It's very crucial that you not miss any pedestrians in front of your car, or that you don't miss any other cars which are in front of your path, basically where you want to drive. So there, it's more about the hit rate, and therefore you can use bounding boxes. And with semantic segmentation, basically, it gives you an additional information on where exactly is that car. So it gives you a more precise information of the location of the car and of overlaps of a car and so on. And also if you have, let's say, a large crowd, it's sometimes difficult to differentiate all the pedestrians and put boxes around all of these individual pedestrians because a lot of the boxes would overlap if you have a large crowd in front of a shopping center, for example. And there, in some cases, instances where semantic segmentation might make more sense because you can distinguish them more. Or in a parking lot, for example, or in a parking garage, also often because the spaces are so tiny, it makes more sense to use semantic segmentation to really distinguish where is a parking spot available, where's a line, where's another parking spot, and so on. It will be difficult to annotate something like a parking spot with a bounding box, for example, because again, there would be a lot of overlap. So these are the 2, let's say, main annotation types, and then we differentiate in the, let's say, input what you have. So either you have a 2D input or a 3D input. So the 3D is mainly sensor fusion, and we have the same categories there again. So we have in 2D, we have boxes and semantic segmentation, but also in the 3D parts on a LiDAR point cloud or in a sensor fusion annotation, you also again have 3 boxes and you have a semantic segmentation. That's I think the rough annotation type. Then there's some smaller annotation types which I did not mention here yet. So there's, for example, lane annotation, which is mainly used for HD mapping and localization, where you just annotate the lane markings, for example. There's also indoor driver monitoring, where you annotate key points. So here's your eye, here's the mouth, here's the nose, and so on. There's another annotation type. There's a lot of variety, but I would say the main annotation types, the most requested annotation types, the boxes and the segmentation, mainly in the 2D and in the 3D area.
What are the industries that you are actually serving? Are you serving industries beyond automotive, or are you fixed with automotive?
We as a company, we are mainly focused on automotive because it's we like the complex task and the difficult tasks. And in automotive, you have with LiDAR and the mix of radar and camera, you have quite a complex setup. So the main use case is automotive, but we see a need in other industries as well. And we're starting to look into other industries as well, where we can apply, let's say, our sensor fusion tooling as well. So we got a lot of inbound requests from drones, for example, because you have a similar problem there with automatically flying drones, where you also have a LiDAR equipped on the drone and you want to recognize pedestrians, you want to recognize certain obstacles in the way of the drone. Flying cars is kind of the new thing after autonomous cars. And I think we have Lilium Aviation in Munich. We have Volocopter here in Karlsruhe. So we have, I think, a few companies in that space, which personally I find also really interesting. And they have to solve very similar problems like the companies have to solve in the autonomous driving space. So we get a certain interest from these industries as well. And then robotics and intralogistics is also a field where we get some requests. But right now, I would say the main part of the business is in automotive, and the main customer base is in automotive. But in the next month and in the next years, we will also go more actively in other verticals.
Really interesting. What is actually your business model? Is it a SaaS model that you give out tools, or do you also take projects like take customers' data and do the annotation using your tool yourself and supply the annotated data? What is your primary business model?
So in the end, we provide a platform which solves the problem of the customer, that he needs to have a lot of data, and he normally needs to manage a workforce. He needs to, let's say, think about automating that. He needs to think about data security and so on. And we provide him with a platform to solve the data annotation problem. And from a business model perspective, we actually found, I think from my perspective and what customers are saying, a very nice business model where we align the incentive and the goals of the customer with what we have in mind. Because I personally believe that breakthroughs will not only come from technical innovations, but also from business model innovations. I think with Google, we saw that was not only PageRank, which made a big difference, but was also their change in business model, which revolutionized the ad industry with their auction-based models. Was something not that many companies, or at least in the ad space, nobody did before. And I personally believe Google would not be that successful if they would only have the technical innovation with the PageRank algorithm, but also, let's say, the business model innovation. And what we, as Understand.ai, what we committed to is that we want to tie our success, or company success and financial success, to the success of the customer. And if we look at what does the customer have in mind, what is his goal, it's mainly the automation part. And therefore, we have a business model from our platform that if the boxes are done automatically by our tool, then we charge a certain amount per box, because this is in the end what provides the value, the number of boxes or the number of images. But if the tool did not automate as much and they needed to do it manually, then there's only a small, basically, infrastructure fee, but not really big. So the main revenue driver, the main part, comes actually from the automation part, and we call this zero-touch technology. So if boxes were touched, we believe they were done manually. Understand.ai did not provide much value, so we will not get much. But if basically the boxes were done or the segmentations were done automatically, then we call this zero-touch annotation, and then we provided more value, and then therefore we get a larger share.
Fascinating. And then what size are we talking about of such typical projects?
So we're normally talking about billions of boxes or billions of annotations which need to be done. And I'm not talking here about these small scale pilots, because this is, I think, which everybody can do with with his interns. I'm really talking about large scale projects, because in autonomous driving, I think we've seen that in the recent years, certain consolidation happened with acquisitions and companies also changing their models and so on. But what we see is that the scale goes up, basically. So the volume of customers requesting data annotation goes up, and we will see, or I assume that will increase further. So we're mainly talking about these large scale volumes, and there, like I said, we're talking about billions of boxes, because how we calculate it. So for a classical validation, you normally need to validate with a few thousand of hours, and every hour has obviously 3,600 seconds, and normally you have around 10 objects, sometimes 20 objects per frame. You normally record with 10, sometimes 20 frames per second. So this is a huge amount of objects which are potentially in these thousands of hours. And this is what drives that amount. And we will see that further increasing, because right now I think a lot of the ADAS level 2, level 3 is focused on highway. And on the highway, we normally don't have that many objects. Once we go into more urban scenarios, we will see an explosion of the number of objects, because in the city you have not only other cars and trucks, but you have lots of pedestrians, you have more street signs, more traffic signs and traffic lights. And we will see then not only 10 or 15 objects per frame on average, but we will see 20, 25 or even more. And this will even increase further the object size. And this is why we believe so much in automation, is that as the volumes are going up, there's no way around automation. Like I said before, you will not be able to hit your SOP dates or your perception KPI milestones if you do not invest in automation, or if you do not look into automation of your ground truth creation, because you will not be able to scale further. You cannot throw just more people at the problem. You have to really automate it as much as possible.
You're talking about the ground truths for validation, right? So this is a very important set of data. And you're talking about billions of annotated objects in automated way. Well, that's a big statement. I'm really excited about it. Yeah, I mean, this is a massive thing. How do you validate the correctness of your annotation?
It's a great question because this is where all the difference will be, because it does not bring any value if you automate everything. You just throw, let's say, a standard algorithm at it. And this is what a lot of our customers, let's say, tried to be in the beginning, because they said, oh, we developed perception systems for our cars, so why can we not use just these algorithms and use them for ground truth automation? And that's a very critical thing, because like you just mentioned, that the quality check and finding the errors in this automatic ground truth creation is super critical. We have algorithms developed which are spotting, let's say, these quality errors, and where we developed also systems which tell us basically where errors, which images, which scans are fine versus which ones do we have to check. And this is where we invested a lot in this quality check. And we often we do samples, for example, as well, to prove to the customer, okay, in this sample, we check this, and statistically, we can prove basically that in this sample, we reach a certain quality via our semi-automated approach. Because just to make this also clear, it's not a fully automated approach, it's a semi-automated approach. So we combine our algorithms with, let's say, our smart review system, where we put humans in, but at the right, let's say, point in time, and at the right, let's say, step of the process, to make sure that the quality is right in the end. And this is, I think, where some of the core IP and one of the core, I think, differentiators of Understand.ai is as well, because normally this is a competing factor, the automation on the one hand, which correlates to throughput increase, and the quality demand on the other hand. And you cannot sacrifice on one of them, especially as you scale further. You cannot sacrifice on the throughput part, but obviously you cannot also scale on the sacrifice on the quality part, because this is a safety critical application, what we are talking about, and we cannot allow any further errors there.
We are actually jointly working on a demo. So to our audience, if you want to know more about the tools of Understand.ai, the technical details of the tool, there will be a Matrix Tech Talk episode that will walk you through a demo project, and you will be able to see today, like Philip mentioned, that we're talking about images, but we're not showing anything. However, stay with us, and as soon as that episode is out, you'll be able to also see the tools. So with that in mind, I have another question, Philip. How about data security? Because you mentioned that you host the data at your premise. So as you know, I don't have to tell you, we're in EU, so nothing can get more stringent in terms of data privacy, data security. How's that handled?
And I think, and this is also an area, I think, where Matrix provides some services and some advice on the security parts and so on. And as you mentioned before, with SOTIF and so on. So how Understand.ai, let's say, deals with the data security part. One important part, which you touched briefly on, is GDPR compliance. As we know today, it's not allowed anymore to just go out there and record data of citizens of the EU and just use the data as we wanted without the consent of the people being recorded. And this is a very, let's say, was a challenge for our customers. And this is why we developed a module there called the UII Anonymizer, which basically automatically, also with deep learning technology, blurs and anonymizes faces and license plates and all other personal identifiable information, so that you can use the data finally. So before, the customers were struggling with that and said, okay, can we use the data? When can we use it? How can we use it? And basically, before the customer shares the data with us or as part of our platform, when he shares the data with us, we automatically removing all personal identifiable information. And this basically was a big relief to the data security officers and so on at these companies, that without this personal identifiable information like faces and license plates, you can just use the data. You can also share it with outside of Europe and so on, because the annotation is normally not done within Europe, the quality checks. So this is one part. We handle the data security with our UI anonymizer, which anonymizes faces and license plates. And the second part is more the infrastructure part. So we have a very restricted and limited authorization and authentication system that only very limited people within the company have access. We are using, obviously, multi-factor authentication, just the classical things, and we're using mainly the public cloud providers, where they have, let's say, hundreds of researchers and IT security guys focusing mainly on securing the cloud infrastructure, and we're not, let's say, relying on our own infrastructure here in the office and have whatever a few IT guys securing it. We're really trusting the public cloud providers because they put a lot of, let's say, emphasis on the data security and IT security.
Fascinating. So you have the anonymizer, data anonymizer, which is one of the key tools for data security and compliance with the GDPR. And is it 100% automated, your data anonymizer?
Yeah, this one is completely anonymized because we don't want to put it in front of people who then see the faces and license plates. So therefore, it's 100% automated tool basically, which can run on premise on the customer side, or runs in our cloud and so on.
I'm approaching my final question to you. Is autonomous vehicle in general is going to be one of the biggest changes. It's going to change our life. It brings a lot more challenges. One of the challenges is data that you're dealing with. In this avenue, being an insider of this industry, what are the main challenges you're facing right now in terms of business challenges, and technological challenges?
So I think the main challenge we see in the market is that a lot of companies are, let's say, trying to reinvent the wheel, I would say. And we saw, I think, a big trend, at least a few years ago, that companies want to build their own tooling for everything. So they build their own simulation tooling, they build their own data annotation tooling, they build a lot of things on their own. And by now we have a lot of homegrown toolings. And now a lot of these companies are coming to us and saying, okay, the in-house tooling, the grown-up thing, it worked great in the beginning when the volumes were small. But as we are scaling up, and what we discussed earlier as well, we will scale up further and we will see further demand and increase in the size and in the volume of data annotation. You start to hit bottlenecks of this in-house tooling. And this is a big challenge, I think, for us and for the industry to now, let's say, find ways around that and to let's say, check and run benchmarks against these in-house toolings, which were developed a few years ago, which are integrated into data pipelines as well, which don't really scale by now. And this is, I think, where Understand.ai can bring a lot of value to, let's say, support these customers in making sure that the data pipelines, as they were built, let's say a few years ago, how can certain elements be replaced within that and basically achieve the scaling challenge. And this is mainly possible, I think, with a huge degree of automation, like we discussed before as well.
Fascinating. Thank you so much, Philip. It was lovely having you. And thank you so much for all the stimulating points and exciting discussions that we had. Thank you so much for watching the episode. And if you have questions, comments to Philip or to me, feel free to write in the comment section. We would definitely get back to you. And I would really, really appreciate if you have gotten value from this episode, then give it a like, hit the thumbs up button. It really helps with the algorithm. And share this video with anyone that you think that would be relevant, and subscribe to our channel. Thank you so much again for watching. Philip, thank you so much for being with us. It was lovely having you.